So just to introduce myself, my name is Nicola and I am the sales and marketing lady at Lascells. If you've not heard of us before, which I hope you have because you've signed up for the webinar, we are a physics equipment manufacturer and we are completely based out of the UK. So we design, manufacture and support all of our equipment from our little factory in Market Drayton. And yes, if you have any Lascelles equipment that might be broken or in the cupboard, and you don't know what to do with it, please do feel free to reach out to us directly. We can do support in terms of repairs and send you spare parts. So that is one of the benefits with us being in the UK. You can pick up the phone to us and we can support all of our equipment with repairs. Now you will notice that I'm not on my own today. I have got Steve with me, who is my better half. And we are filming out of Keele University. Steve, would you like to introduce yourself?
Thank you very much. Yeah, so I describe myself as the better half, but I am the other half of this partnership. And I'm a lecturer at Keele University, physics lecturer. We're in one of the project labs today, and yeah, I teach all 4 years on our course. I do a bit of everything. I'm probably primarily laboratory and stuff like that, based on it.
Yeah, so basically you've got 2 physics nerds for the price of 1 today.
I'm your glamorous assistant today, aren't you?
Yes, you are my glamorous assistant. Don't go anywhere. So yeah, we're based at Keele University today, and this is where I do all my YouTube videos from. So if you haven't seen our YouTube channel, please feel free to check that out. I make a load of videos on things like required practicals and teacher demos and how to use our equipment. So hopefully it's a really useful resource. You can find us on YouTube and our handle is @Lascelles Science. Now, yeah, I'm really thankful to Keele and you for letting me use your labs for the videos. I think it's really important to point out that maybe the smaller universities like Keele are struggling at the moment. Everyone will be familiar with the cutbacks in education, so schools are obviously struggling that you are aware of. But it's also hitting the higher education sector. So when students come to you and say, what university should I be applying for? Definitely don't forget the smaller ones. These are the ones that really need your help. So if you're taking notes, please make sure that your first one is to reach out to your local university to see what maybe like outreach activities that they can offer you, because they will be screaming out to interact with you. Steve, you do some outreach work for Keele, isn't that right?
Yes, I've previously been the outreach lead for the physics department, and I did some outreach yesterday actually with a local school. Some Lascelles DIY speaker kit, which went down very well actually, and they enjoyed making that. But yeah, contact your local one if you're local to us, or our recruitment department do travel all over the UK. We do outreach on various things. You can come to the university, or we can come out to you and do different bits. Our astrophysics department has a large star dome, which is a big tent essentially, and they project lots of pretty images and talk about lots of astrophysics and get all years interested in studying astrophysics and the big questions of the universe and things like that. But no, feel free to reach out to our department. Just Google or AI physics at Keele or your local university and get in touch and try and start those partnerships and stuff like that. It's obviously very important universities collaborate with local schools and local businesses and things like that and help the community.
Yeah. So there's a worrying trend as well that some of the smaller universities are closing physics and chemistry departments. And the IOP and the RSC have put out a report that says just how important the smaller institutions are in terms of like a rich, diverse research field, and also widening participation. So making sure that those students from maybe low socioeconomic backgrounds that maybe don't have the funds to move far away from home to go to university, just to make sure that they also have access to that higher education. So yeah, please do make sure you reach out to your local university. I'm sure they would love to partner with you. If you haven't heard of Keele, we are based in Stoke-on-Trent. So we're within like an hour radius of places like Birmingham and Manchester, Liverpool, Chester. So it probably covers a wider range than you would think. But yes, shall we get on to talking about some equipment?
Yep.
Right, okay. So the first thing I want to show you today, guys, I'm going to show you loads and loads of stuff. It's going to be a bit of a whistle-stop tour. But yeah, just to try and pack as much in as possible. First thing I want to show you today is something called our E-field detector. So this is essentially a charge detector, and the sensitive element is on the top, and this can measure charge. So on the front of it, you'll be able to see that we have a plus and minus sign. So this means that it can see charge and also see what polarity intensity it is. It can also give you a magnitude of that charge because we have like a string of LEDs on the front, and depending on how many LEDs light up, it's proportional to the amount of charge that it can detect. So in terms of turning this on, I've supplied it with mains voltage, and I am going to turn it on. It's already on, actually. None of the LEDs are lighting, so this means that there's no static charge in the air. So first off, balloon please, sir. Do you want to rub that on your head, please?
Camera shot.
Right, that'll do. So I'm going to get the detector, show it to the balloon, and you can see that we now have lots of negative charge. It's really lit up in the blue region. But so what this is showing is that we've got lots of negative charge, and that means we have a surplus of electrons on the balloon. But where have those electrons come from? If we show this to your head, oh, it's just about trying. Can you see? Oh, there's like the light up there. You can see that we've got some red lights here. So this is showing that now there's a positive charge on Stephen's hair. So this is where the electrons have come from. So really with this, we are showing visually that transfer of electrons, that transfer of charge between the head and the balloon. Now, if we didn't have this piece of equipment, the demo would literally look like a piece of plastic pipe and a cloth, and we give that a rub, and then the teacher would say, and there we go, we have electrons on one and electron holes on the other. One is positive, one is negative, but it's not very convincing. Your student really has to think, okay, if you say so. But then with this piece of equipment, it makes that much more accessible. Now, will you hold this for a second, please? Thank you. So with one type of plastic, if I give this a rub, we can show it to the detector and show that this gains electrons. It's gone very negative. And then with another type of plastic, I can give this one a rub. Show this one becomes positive, so this one loses electrons. So you could get your students to investigate lots of different types of materials in the triboelectric series and see which ones like electrons, which ones don't. And with this, you can also use it for the photoelectric effect. You like shining it, yeah, don't you?
I've seen if there's not many electrons in my head.
Yeah, you can use it for the photoelectric effect. It's essentially like a newer version of a gold leaf electroscope. It has voltmeter sockets on the back, so you can put it into a voltmeter and do things like the inverse square law just by dragging it away from a charged object. And we send this to you with like a calibration graph. So you can turn that voltage into picocoulombs, into charge, and get nice quantitative results from it. The IOP have had hands on this piece of equipment, and they've given it 5 out of 5 stars, so they couldn't have higher praise for it. We're really proud of it, but just not many people know about it. So I wanted to make sure that you guys have definitely seen it and seen what it's capable of. If there's any questions, please feel free to put them in the Q&A, and Gary, just shout up when there's one that you can't answer. Right, moving on.
Sorry, no.
Right, so next we have got the Newton scales. So this is essentially what is it called again? This one is called the E-field detector. Yeah, so if you just type in E-field detector into a search bar on the SLS website, it will come up. I don't think it's overly expensive. Gary will be able to give you that information in the chat. Sorry, Gary, giving you jobs.
That's fine.
Yes.
I'll send a direct link into it so you can see the price and specifications on the website.
Amazing, thank you. That's super helpful. Right, so moving on to the Newton scales. These are essentially bathroom scales, but they have a Newton readout on them. So instead of reading out in kilos or in stones and pounds, it will give you the actual force reading. So this is to kind of combat the misconception that when you stand on your bathroom scales at home, you are taking your weight. You aren't, you're just measuring your mass. Obviously weight is mass times gravity, it's the force. So it's a magnitude and a direction, which is downwards. So with this, we can do some fun activities. So you can just stand on them and get your force reading out of it. And that makes it a bit more, shall we say, less embarrassing, because no one really wants to reveal their weight. But when it's hidden behind newtons, there's nothing really to be embarrassed about. Obviously, you can do the maths. But
by 10, but yeah.
Yeah. But it just makes it that slight bit more complicated. So shall we test our grip strength? What we can do is we press this really hard and see where we get to.
Gentlemanly 100.
It's much easier to do it when it's facing you. But the nice thing about this is that it's kind of really engaging and you can do a whole class competition of how hard can you grip. And definitely those students that maybe think that they're a bit too cool and a bit too hard to do physics, they would really enjoy this kind of activity and kind of proving to the rest of the class how strong they are. The other nice thing that you can do with them is Newton's third law, which is equal and opposite reactions. Yes?
Yes.
Would you mind holding your scales up to me? Oh, right. And then if we push, don't knock me off my chair. About 100?
Yeah.
Yeah. Okay. So this is showing equal and opposite. So basically every action has an equal and opposite reaction.
Yeah.
So that's just a really nice accessible piece of equipment, which is relatively cheap as well. All available on the SLS website. Now, the last one for this camera angle before we start messing around and changing camera angle.
Yeah.
Hopefully that'll go okay. Yeah. I want to show you our Boyle's Law piece of equipment. So this is to, bear with me. This is kind of in competition with maybe the bigger pieces of Boyle's Law equipment that you see. It's kind of like a wooden mounted base and a big cylinder on it. Obviously, those are really difficult to store. Maybe you would only have one of them per class as a teacher demo. With this one, it's nice and affordable, and you can see that it's super, super small. So you can fit several of these in a grapnels tray. With the big ones with the cylinder, they are prone to leaking and they can be a bit unreliable. They've got an analog scale on, so maybe taking the readings isn't quite straightforward. With this, everything is digital. So remember, Boyle's Law is the relationship between pressure and volume. So to change the pressure, all you've got to do is, let me turn it on so you can see it working. It's got a little flick switch on the front of it just to turn it on. To change the volume, literally just change the volume in the cylinder, and then you'll get an instant readout of pressure on the digital display up here. It's all in essentially SI units. It's in kilopascals, so there's no nasty conversion to do. And you'll see that we've got sockets on the front as well. So if you wanted to turn this into a big teacher demo, you can do it at the front of the class. You put a big demo voltmeter in here so you can see the analog meter swinging from side to side, and you can take this off and attach like a really big cylinder to it, and then get one of the kids to have a go at pumping this syringe. And yeah, it's just a really nice piece of equipment. All of your students can get hands-on and get their own data for Boyle's Law. It just makes it a lot more accessible than just the one teacher unit at the front. You'll notice as well, I haven't had to plug any of this in. It's got a battery pack on the side, so you don't have to rely on any main sockets for that one. Right.
What's that one called? Just say.
Boyle's Law.
Boyle's Law.
Boyle's Law, digital Boyle's Law apparatus. Again, all available on the SLS website. For this one, I have done a full walkthrough of the required practical. So please, again, check that out on our Lascells YouTube channel. I show you exactly what the data should look like, what you need to plot, what you can do with the data once you've got it. So yeah, entire walkthrough all on YouTube. Right. Shall we have a go at changing the camera angle?
All right.
Right, bear with us. This might be a little bit clunky. So we need it on your camera.
Yeah.
Yeah. And I will stop sharing my thing on here and spotlight you when you come on if I can find you. Is there any outstanding questions, Gary, while we just take a minute to do that?
At the moment, I wouldn't say so. A lot of people are asking again, like what was the equipment called and pricing and things like that.
Oh, okay.
So yeah, I think we're good for now.
Nice.
So while Nick's changing her camera angles, I thought I'd let you all know Lascells do have their own YouTube channel where they put on a lot of good videos, most of which I think Nick appears in. It was an option
Rory
to
sometimes.
and Rory, yeah, it was an option to show you the videos today, but me and Nick thought it'd be much more fun if we do live demonstrations because that's what people prefer.
Oh yeah, you can watch them at any point. Yeah.
Exactly. Yeah. So let's hope this goes well.
Right, Steve, I've found your feed. Thank you very much. I'm spotlighting you for everybody.
Okay.
It's
Perfect.
looking good. Yeah.
Microphone on here.
Yeah, microphone on there. I'll turn this one off so we don't get any feedback. Sting, can everybody hear me? Yeah.
Okay. Can hear you. It's a little bit quiet, but we can hear you.
Okay, how are you feeling about the camera, dear?
Think it's working?
Yeah, okay. Right, so this is our party piece, really. This is the piece of equipment that we are known for. It is our mini ripple tank. It is all plugged in, and then to turn it on, actually, let me show you in the front first. We have got one of the dippers here. I'll just take this off so you can see. So we have a central stem here, which is essentially the wave vibrator. And when you buy the ripple tank, you will get all of these accessories with it. So you get a plain wave dipper, a point source dipper, a 2-point source dipper, 2 L reflection plates, and 1 parabolic reflection plate. You'll also, you'll also get some acrylic shapes to do refraction with. So you get this wedge shape one, and a concave and a convex lens, if I can put them at the right angle. Right, so I've already put water in here. This tray comes out so you can easily fill it up and take it away. And the dipper that we will be using the most is the plain wave dipper, this one. So to attach it, I'm just going to put it on this stem. Oh. And I want to make sure that my dipper is just touching the surface of the water, which it is. I'm going to close the lid and turn the waves to on. And we also need some light. I'm going to put it on free. And then hopefully you can see some waves traveling down the tank. Yeah, could you maybe turn the light on? Fabulous. So there might be some interference effects here. I apologise for that. There's not really that much we can do about it. But can you hopefully see the waves traveling down the screen?
Would you like a close-up?
Yes, let's try a close-up. It's not easy to see at the moment. That's much better, yeah.
So you have some strobe effects with the LED frequency and the phone's camera frequency as well.
Do you know what? It might actually be better if we could try and hoist it right above it and look down on it. You can't see it at all on that. Shall we? How do we do that? Is it this one?
Rehearsed for that.
We haven't rehearsed for that, have we? Oh, here we go. Da-da-da. Put that about there. Oh, that's as low as it can go, though, isn't it? It can't bend over anymore.
Yeah. Oh, right.
Right, we might have to go freehand. Sorry if this is going to make anyone feel a bit motion sick. Right.
It's a good image at the moment.
Yeah, okay, cool. So, do you want to get that out of the way? I can swivel it over here. Thanks. Right, so you might be able to see that the lines aren't perfectly straight. So if you want to combat this, my best tip for you would be get a little bit of washing up liquid, put it on the end of your finger, like this. And then we open up the tank and we just want to wipe that. I'm going to turn the waves off. I'm going to wipe that around the edge of the tank. And guess what this is doing, Stephen?
Wiping washing up liquid on the edge of the tank.
Reducing the surface tension. Right, so if I put this on, now you can see that we've got lovely straight lines. So this is the biggest hack for ripple tanks. Make sure you always have some washing up liquid ready. So like I say, this is with the plain wave dipper, so we've got lovely straight waves. I can adjust the frequency by adjusting the waves knob on the front and make them travel slowly or stop altogether or travel super, super fast. On the front of the ripple tank, there's also options for the strobe, so you can have it on free or sync. So when I flick it on to sync, you should be able to see that that matches the strobe to the wave dipper and basically just freezes the wave pattern. So this is important for measuring wavelength, which is part of the required practical for the ripple tank. And for that, we would recommend that you print out a millimeter scale on acetate sheet, which I've done here. You can simply lie this in the bottom of the ripple tank. Ooh. And it will project up through the screen, and there you have it, that lovely millimeter scale. The other one is measuring wave frequency. So to do that, you want your waves traveling slowly. So I need to put that back on free. So yeah, you want them basically moving nice and slow. And then in the required practical, it says pick a point on there and measure how many waves go past in 10 seconds. Now, when I was doing that, I found it really difficult because it's like, do you look at the screen or do you look at the stopwatch? So what I would recommend is definitely still pick a point on there, but then count how long it takes for 10 waves to travel past. So then you don't end up like halfway through a wavelength and that fractional reading ends up on the stopwatch. I go through all of that in one of the YouTube videos. It just makes your measurement a little less error heavy. But yeah, definitely check that out. With the ripple tank, you can do everything, all the kind of required practicals that you'd have to do with the ripple tank. So like reflection, refraction, interference and diffraction. So just to show you a couple of those, obviously we have the plane wave dipper in at the moment, making these nice plane waves. So for diffraction, we want the 2 metal L plates, and I want to fence in some waves. So if I do this, now you can see we've got plane waves coming in, and they go through the aperture, and we get that nice circular diffraction happening going through there. Can you see that? Hopefully you can.
It's very faint, but I can see it.
Is it very faint? Okay.
That practical is always, I find, the hardest of the ripple tank.
Oh, one. Really?
Yeah. No, I can get to work, but yeah, I can see it.
Okay, let me see if I can just adjust this aperture ever so slightly. So diffraction effects are most appreciable when the aperture is equal to the wavelength. Maybe it needs to be a bit closer than that. Let's have a quick. It does look very faint. I think it's because it's relatively bright in here, but yeah, you can definitely see it. Again, I've gone through this on a YouTube video, so it might be slightly better quality on there, so please do feel free to check it out. In the like in real life, it's definitely easy to see. Let me show you what reflection from a curved surface looks like as well while we're here. So I'm putting the big parabolic reflector in, and if I adjust the wave frequency, you should see it trying to do its thing. I'm going to put it on to sync 2. So here you can see as I slightly change the wavelength, you can see that we've got a focal point happening just here. So what's happening here is we've got plane waves coming in, and they are all being reflected by this mirror to a focal point. So this is why when you look at sky dishes on the side of someone's house, you always see that they've got the dish, but then they've also got that receiver arm, and that receiver arm is placed at this focal point. So that is what picks up that lovely clean signal. So this is a really nice demonstration of a real world application of how we receive TV shows at our house. Really cool. I'll show you how to do just normal reflection as well. All you've got to do is just bang one of these metal reflectors in. Oh, can't really see that very well. Try a slightly different angle. So you can just about see it. We've got waves coming in, and then there's a secondary wave coming out with wavefronts in this direction. It is quite faint though, but I definitely can see it here.
I can confirm I can see it.
Yeah. Amazing. Right, so let me just show you what the other dippers look like. If I turn the dipper, the wave driver off, just to remove this, I will put the dual source dipper in there. Here we go.
Nick, is it possible to get all these little accessories separate if someone needs a replacement?
Yeah, absolutely. So we do spare dipper sets and spare reflection plates, and all of the lenses come as a separate as well. So yeah, if you've lost anything, please let us know, and we can definitely sort that out for you.
Okay.
Let me just push that on a little bit further. It's really bright, isn't it? I wonder if we can turn them lights off. If it would make it any better. We need a viewing hood is what we need.
Possibly.
So yeah, we're under a bit of a skylight, so it's not getting the best contrast. Oh, here we go. If I go up to a higher frequency. Here we've got 2 coherent sources, and they are basically doing some interference effects for us. Sometimes these are a bit more appreciable when we haven't put washing up liquid in there. But have I got a pen to point with? Or a screwdriver, that'll do. But you can see that we have some areas where the peaks are adding together and where the troughs are cancelling out. So you can kind of see constructive and destructive interference from these coherent sources. Again, it does work slightly better when you've got higher contrast, but I think you can just about see it. So there's that one. And then just to show you what a single point dipper looks like. Oh, put him on. There we go. So then it's just an example of a circular or spherical wave. Thank you very much. But yeah, this is definitely our show pony piece. It's one of the pieces of equipment that we sell the most units of. It's nice and small, so it means that students can have it on their bench and they can put their hands in there and do all the experiments themselves. Some of the other ripple tanks that you've got to attach legs to, they can be relatively unstable and they need a lot of leveling. With this, it doesn't have any of the hassle of the setup, and when you're trying to put it away, one of the legs isn't going to collapse and water's going to go everywhere. So yeah, we really like this piece of equipment. Cleeps, the Ogden Trust and physics partners also use it for their training, and the IOP have rated this piece of equipment 4.5 stars out of 5. So yeah, we absolutely love this one, and we get really good feedback actually from lots of schools. Right, shall
Nice
we?
visualization. That.
Yeah, oh, visualization, very good point, Steve. So if you wanted to use a visualizer with this, you absolutely can. But what you also can do is if you just simply open up the tank, you can just get that ripple effect on your ceiling, provided you've got like a flat clear ceiling with not much pattern on there. You can definitely see the pattern. If you wanted to do that as a colour, you can always add food colouring to the tank, and you can project like green waves, for example, or blue waves. We can also put in some acetate sheet. Getting blinded by the light. If I put some acetate sheet in here, you can see that it makes the field of view blue. So if you wanted to add some colour to this experiment and let students choose what colour they want their wave patterns to be, that's definitely one way of doing it. In terms of projecting it onto the roof, though, you won't be able to do that with the acetate sheet just because it knocks too much brightness out of the light. So yeah, if you want to get that long field of view projection, then definitely use food colouring. We did that in a YouTube video recently, and it works really, really, really well.
Could be very useful for inclusivity as well, I guess, is that?
Yeah, yeah, definitely.
And
I think
certain colours to see it.
Yeah, green definitely increases the visibility as well, I think. So yeah, it's a nice one. We'll also mention this. This is our little frequency counter. So all you've got to do is just plonk this on top of the ripple tank, and you'll see that it's giving out a frequency reading. So this is frequency in hertz. So if you wanted to ever check what frequency the strobe is at, this will give you that. So this is a little addition for the ripple tank. It doesn't come with it. It's an additional, but again, it's not too expensive. You'll see we haven't even put this in a box just to try and make it as cheap as possible. So it's ideal for use with the ripple tank, but you can use it on any strobe source to get the frequency of it. Lovely. Right, shall we move on to another show pony piece and do the cloud chamber?
Yeah.
Yeah, we've moved that now, haven't we?
Yeah. Hang on,
Okay.
that's going to go all the way around.
Right, bear with me again, guys.
No problem.
If you have any questions, oh, go on.
I'll just reply to a few. I think most know the answer. It's like the brightness of the LED. That can't be changed in a ripple tank, can it?
No, it's a nominal
It's
brightness.
set.
Yeah.
I thought so.
A lot of those strobing effects you witnessed though are due to the camera, the phone camera.
Yeah.
Oh yeah, in person it is a lot clearer. As soon as you use a camera, you get, like I say, those funny lines appear.
Yeah. If that happens on your visualizer, what we'd recommend is that you turn your ripple tank like 90 degrees so that the interference from the camera is like moving in a perpendicular direction to the waves, so there's no confusion. It does help a bit.
I find new cameras are actually better than the old cameras. If you have like a new mobile phone, sometimes you don't get any strobe effect at all.
Oh, seriously? Maybe they've done something to counteract it.
I think they have.
I should mention as well, refraction is super easy in that ripple tank. I've also done a video on that, so if you want to check that out, please do feel free. It's definitely one of the questions that we get asked the most about the ripple tank. Can it do refraction? Because it's a nightmare. And the answer is yes, and it's super, super easy. Right.
One question I've had a few times, Nick, and I've never known the answer, but I think a technician just gave it to me. Is when you press sync on the ripple tank, how does it work that it all freezes?
So that just matches the strobe light frequency to the wave driver frequency. And when you have two frequencies that match, that's just when something looks stationary. Yeah. So okay. It's like a trick of the eye, isn't it? Really, I guess.
Yeah.
Yeah.
No, that's really clever. And
the same thing, like when you like you're driving in your car and you look at a car that's also moving, sometimes their wheels look like they're moving in slow motion, don't they? And it's kind of like oversampling or undersampling. It's like a slight difference in the frequency of your eyes and the wheel going around.
Strobe effect into you can video helicopters and you can it looks like the blades are stationary. It's just because the camera frequency is the same frequency as the rotational frequency of the blades.
It's a nice little bit of optical physics, that one. Right, so now we have moved on to the cloud chamber. This is our thermoelectric cloud chamber. To get it to work, all we've got to do is plug it in, give it mains power, and turn it on, and supply it with some alcohol. So what we want to do is get some isopropyl alcohol or propan-2-ol and get some in a syringe. My amounts of this getting low. Now, with the lid, you can see that it's got holes in it. Oh, I haven't got enough hands. Can you undo the vents on there for me, please? Thank you very much. So you'll see that there is like a felt bed on the underneath of this lid. And the idea is that we wet that felt bed with isopropyl alcohol. Is that leaking? I'm not sure. Now you can jimmy the, what's it called? Pipette in through this hole, but I actually find you have slightly better control if you just do it like this. So here I'm just going to pipette some alcohol onto this bed, and we want it nice and saturated. I'm going to hold that a sec. It's because I'm running so low on alcohol, I've got to tilt the bottle. Thanks. Can everyone see? Yeah. Put a bit more on that bit. So it's really important that this is isopropyl alcohol. We had a question not too long ago where someone was putting the wrong type of alcohol or maybe a contaminated bit of alcohol in the cloud chamber, and she was getting some really nice crystals, which I've never seen before. But yeah, it just turns out that her alcohol sample was contaminated. So if ever it's not quite working right, just check that you're definitely using the right type of alcohol. I think that's all of the sections done now, isn't it? Ooh. Thank you. Right, so what we're going to do is we're going to put this source, which is a thoriated tungsten welding rod, in the camera. It's got these little bits of yellow on it, and that's just to make sure that the source sits outside of the alcohol puddle. I'm going to plonk that in here. And then Steve, if you wouldn't mind putting the lid on. So what's really important, we need to make sure that the plastic base is firmly secured. And we need to make sure that the lid vents are closed. This makes a nice closed system. I'm going to turn the chamber on. I'm going to turn the LED on. And now all we need to do is just wait for the alcohol to evaporate into the air. And then it's going to condense down onto this cold plate. So basically what we've got here is a Peltier device, which is a semiconductor material. When we pass a voltage through it, one side's going to get hot, the other side's going to get cold. We've put the cold side up, and that's what the alcohol is going to condense onto. And then occasionally this welding rod is going to spit out some alpha particles and leave lovely traces showing that it's emitting radiation. Now, hopefully we're going to be at the right angle for this. We might have to jimmy around with the camera again, but we'll just wait for that to cool down. And yeah, we'll move it if we need to.
I think it's normally a few minutes till you get the first sign of streaks, isn't it?
Yeah, that's right. So that's also a reason why I wanted to do it in real time. So you know that it hasn't been running and taking forever to get to temperature. It literally just takes a couple of minutes.
No, it is very fast. I've used it before. While we're waiting, there's a couple of questions about the ripple tank which have come in.
Go on. Yep.
Is the bulb easy to change if the bulb goes wrong? I've never known one to go wrong myself, but
I've never known one to go wrong either. That's a very good question. Like I say, all of our equipment is supported, so if it did break, that's definitely something we can do. I've worked at Lascells now since 2023 and been working with them since 2015. And yeah, I've never heard of that as a failure. So I think it's very, very atypical. But yeah, absolutely, we'd be able to support you through that.
Yeah, likewise, we've sold this product for a very long time and I've never had anyone tell me their LED bulb has stopped working. Another question, I think I know the answer to this one, but would the ripple tank be suitable for children with epilepsy? Is it because it's just a strobe that
So our ripple tank only operates at the region in the strobe region that is least likely to affect someone with epilepsy. So yeah, we've kind of just not let it go down to those like really dangerous frequencies. So although we can't guarantee that it wouldn't, we've definitely made sure that it's least likely to be able to do that.
I'm seeing some nice streaks now from the
Can you see that? Yeah, we can see it.
Yeah.
So yeah, sorry, we've gone freehand again, but hopefully you can see them. We're getting some background ones there actually as well. Did you see them? They definitely weren't coming from the rod. Whoa.
Yeah, there's a few more there.
They're physics lab, so there should be some particles.
Oh, it's doing its thing lovely. So like I say, this is a thoriated tungsten welding rod. It's spitting out alpha particles. So the big straight tracks you can see are alpha particles. So 2 protons, 2 neutrons. And then some of the little curly ones you can see, those are electrons. So electrons are obviously a lot smaller than alpha particles. So they get deflected more easy as they travel through the air. That's why you get bent tracks. I've also done a couple of videos on this, so you can check them out on YouTube. It goes into a bit more about what a cloud chamber is, why it's important in the classroom, and exactly why you're seeing what you're seeing. Should we try the balloon thing?
I was going to say, yeah, our students particularly like just this visualization of seeing the radioactivity that's around them. So yeah, the thoriated rod is a standard welding rod. They just add a bit of thorium for the properties of welding. But yeah, and the half-life is billions of years, so you're not going to have to buy many of these
It
welding
should have
rods.
the lifetime of your school, shouldn't it?
It should do, yeah.
I think we had a look before. Is it like tens of billions of years?
It's the order, yeah.
Right, so this is massive actually. Do you reckon I cut that in half? Or?
If you want to.
Oh, I don't know. Or do I just shove
Shove it down the one end.
You reckon? Right, so what we've done here is we statically charged a balloon earlier and stuck it to the wall. So what this means is it's collected a lot of radioactive dust in the air, hopefully, and this means that we can use it as a radioactive source. So if I bring this guy out and shove this thing in, see what happens. Hopefully it works.
So it's good to talk about background radiation and stuff like that. People often misconceive that radiation is all human-made.
I can't see anything.
Can't quite see any, actually.
Oh, there was one.
Oh, yeah.
There's another one.
Oh, there's
loads.
lots now,
Here we
yeah.
go.
Can you? Is everyone able to see that?
Yeah, I can see a few.
So you can see now the activity has absolutely skyrocketed, and this is really important because it's sampling the air that your students are breathing, right? So it's actually created above background source, and it's just a really interesting thing to get your students talking about the amount of radioactivity that's actually in the air.
So about half of your radiation dose that you receive naturally is from radon in the air. And depending where people are at the moment, there are areas of the UK that are more radioactive than others. So we're actually not very radioactive in the Midlands, but Cornwall, the Peak District, places like that with exposed rock, you have significant, well, you have elevated levels of background radiation. Few more times than what we're experiencing.
Didn't you say somewhere in Germany it's got like 10 times the amount of background?
Yes, with high thorium deposits actually.
Is it really?
Yeah, Black Forest.
No way, so thorium's just like naturally occurring, it's just around.
Yeah.
Yeah, okay.
The thoriated rod you use with the cloud chamber, I know it's a very weak radioactive source. Would it have to be kept with radioactive sources locked away, or it's so weak you'd have to worry about that?
If you have somewhere specific, it might be wise to keep it in there just so you don't lose it, so that every time you think, oh my gosh, I want my cloud chamber, but I don't know where the rod's gone, you obviously know it's always in that cupboard. If you don't have a particular radiation cabinet, then honestly it really doesn't matter.
There's no protection issues associated with it. As you can see, this balloon is more radioactive than that thoriated rod, so you wouldn't have to worry about keeping it on you. And you can buy it from the shop in large quantities.
Yeah.
Thank you.
If you have a look at the CLEEPS guidelines as well, they just say it's a part of the standard holding. So yeah, there's no regulations with it at all. The only point at which the rod would become dangerous is if you start like grinding it up or sawing it in half or something like that. So obviously don't do that. Obviously, as soon as you do that, you'd be inhaling the dust, and that's when it becomes an internal hazard rather than external. But yeah, it's completely harmless.
It would still be at levels that wouldn't be significant.
Yeah. So yeah, hopefully that's shown you a really cool experiment that you can do with a balloon. You don't necessarily need a fancy source to get lots of activity in a cloud chamber. I'm really glad that worked. I did do it in a school once, I will warn you. I did do it in a school with massive windows and loads of ventilation in a classroom, and it didn't do anything. So I think it does depend on having some like stagnant air in the room. And like I did say, we are kind of in a basement at the moment, and radon is a heavy gas, it sinks. So if your school has a basement, definitely do it down there because you'll get really, really, really good results.
I've also heard it doesn't work quite as well if it's a very hot day.
Yes, that can affect it. So it just means that it has to work really hard to cool itself down. But I have done a video that gives you lots and lots of tips and tricks onto how to combat that. So yeah, definitely check that out if you are struggling. Again, we can fix these. So if you've had it for a while and it's not working quite as well as it should, you can always send it back to us and we can get it running for you again in no time at all. Someone did actually come all the way over from Sweden to get one fixed. Bought it over in his hand luggage on the plane. So it just goes to show how much he loves it. He wanted to get it up and running again. But yeah, we can do that for you, no problem. Thank you.
So someone's asked, can you use other radioactive sources with it? And I think you can, but the trick is that rod, the shape of the rod makes it work really good, doesn't it? So
they can be any shape. Obviously, we're kind of just looking at a plane in the cloud chamber, so it kind of has to sit at the right level. You've got some lovely radioactive sources here, haven't you, that we've had a look at? I say lovely, I mean very high activity.
You just need to direct them into that.
Yeah, that's it, isn't it?
Cloud is, yeah. And
sometimes when they're really strong, you kind of just get a flood field of radiation, so you can't really pinpoint like specific traces. It's just a constant barrage. I think also we've put a video of that on our Lascells Instagram page. But yeah, you can definitely try the sources in there, get your students to have a look at it, and yeah, it's a lovely piece of equipment. Some experiments that you can do is you can try wrapping the rod in different materials and seeing if that stops the alpha getting out.
So you can wrap it in paper and that should stop it.
Yeah. Tin foil.
That's what I'm thinking about. I did, yeah.
Yeah. So yeah, that's a nice way to kind of extend what you can do with the cloud chamber. But obviously this doesn't use any dry ice. I understand from talking to some technicians that dry ice, or like ordering dry ice, is a pain in the bum, because it's expensive. You can only get deliveries on certain days. And it's a pain. With that, all you've got to do is turn it on, put some alcohol in there, and you are ready to go. Right, moving on to the next thing. Here I have got a reaction timer. So this is a biology required practical. And it's also very important for physics, understanding the human reaction time. So what I've got here is a millisecond timer. This is the same timer that works with some of our light gates. With all of our light gates, we only do one type. And it also works with our G by freefall kit. And this is the reaction timer part that I've just plugged in. So I've got the start gate in the start gate socket and the stop gate in the stop gate socket. So super easy to set up. So all we have to do here is we have to just press reset. So the millisecond timer is ready to start recording. We have to press green to let the timer know that we're ready, and then red when this turns red. So I'm going to press green, the light's going to go off, it's going to come back as red, and then I have to press red to tell it to stop. So I'm going to have a go, and then Steve, you're going to have to see if you can beat me, okay? So I'm going to press green, and then concentrate. Oh my gosh, terrible. So 0.238 milliseconds on the timer. Just make sure you guys can see that. So average human reaction time is 0.25 milliseconds. So it does mean I'm slightly better than average, but not very much. The pressure was on with loads of people watching me. Did you want to have a go, Steve?
Of course. Again, you're getting the unruly students to get involved there.
So this piece of equipment brings out everyone's, oh my goodness me, it's absolutely trounced me. So Steve got 0.181. So this piece of equipment brings out everyone's competitive side. You can turn it into like a beat the teacher activity, which you actually do, don't you, already with something?
I give out a free chocolate bar if they can beat me.
And yeah, I've also done a YouTube video on this where if you get your students to take like 30 repeat readings, they can plot like a normal distribution of the data, do some really nice statistics on there, like standard deviation and error analysis. It's a really lovely piece of equipment, and I guarantee that everyone in your classroom is going to want to have a go at that. It's awesome. Shall we quickly move on to the next one? How are we doing for time?
It's 5 at the moment.
You're doing okay. It's time's been flying by, but so we scheduled now, but it's no problem if you go over an hour.
Sure. Okay. Should we do something fun? Should we do him? Resonance shoe?
Yeah.
Oh, actually, no, because we'll have to change the camera angle maybe. Let's just quickly do this one. So I want to show you our little battery eliminator. So quite a few people don't actually know what this product is. So let me just quickly explain it. It is a little power supply, which essentially eliminates the need for batteries. Oh, I can move. Don't worry about moving that. I can move this so it's in. Okay. It eliminates the need for batteries in the science department. So if I just quickly unplug this voltmeter so you can see it a bit better. Ooh. Here you can see that I am using it just to power 3 bulbs, and these are in series. So if I crank it up to the maximum of 12 volts, you can see that the bulbs are relatively bright. And then if I tune it down, you can see that the bulbs are decreasing in intensity. They are sharing that voltage. But yeah, the battery eliminator is basically to reduce your science department's need for batteries. So anything that you'd want to use batteries for, you can simply wheel this out, plug it in, and tune it into whatever battery voltage you want. So we've got 1.5, 3, 4.5, 6, 9, and 12 volt output on here. So yeah, with this experiment, if I crank it up to 12 volts on the output, I can then attach a voltmeter across one of the bulbs and look how many volts it's eating. If I turn that on, you can see that it's taking about 4.15 volts. So 4 times 3 gets us to 12. It's showing that that voltage is being shared across all 3. You can do it in parallel as well and show that all the bulbs are taking the same voltage, but it's just a lovely piece of equipment so that you don't have to worry about keeping a huge inventory of batteries, all of different types. It just gives you a little more breathing space with respect to battery usage.
Are they lockable, Nick?
They're not lockable, these ones, no. So this is our answer to maybe those people that want a good power supply but don't quite have the budget for it. We do our bigger Lascells power supplies, which have got the voltage lock on there. So in the Cleeps buying guide for power supplies, the big power supplies that we do tick off every single requirement that Cleeps say you should have. And this is just like a cheaper alternative to those, essentially. Yeah.
Yep.
Okay. Right. Him?
Mm-hmm.
Okay. Right. So I want to show you something super exciting now. This is our resonance tube. I'm going to come back a bit. Ooh. Do I need to come this way or that way? Here we go. Ooh. Okay, so this is our amplified resonance tube. We also do a small bore one for cork dust. This has got polystyrene balls in there. We have a big speaker on one end, and then with speakers that we need to attach them to a signal generator, not a DC power supply. So I've also got our Lascells SigGen here. Show you that? No, it's not quite in. Oh, I think it's frozen. Oh, here we go. Right, okay, so you can just about see the SigGen in the frame now. This is plugged into the speaker on this end. So what I'm going to do is it's going to get loud in a minute, guys. Let me just warn you, you might want to turn your speakers down on your PCs. So I'm going to set it to the first resonant frequency and you should see these balls start to dance. So bear with me. I'm going to take it to the frequency first and then ramp up the volume just so it's not too annoying. Sorry.
It looks really good.
So it wouldn't be physics if it wasn't noisy, but hopefully what you saw was 2 peaks demonstrating where the nodes and antinodes are in the standing wave column. So at every resonant frequency, you will get striation patterns like that. I will just take you up to the next one. So as we go to the higher resonant frequencies, the kind of like height of the balls does drop off, but you can definitely still see it. You can do loads of experiments with this one, exactly the same as you can do with the smaller bore tube. I've done a really extensive video on that on YouTube, so please do check that out. But yeah, Gary, do you want to stop now, or what do you think?
Have you got more you'd like to show?
Well, I've got a couple more we can show, but it just depends whether there's time.
Well, I say it's not a hard stop. So if you want to show a couple more things, we can. We're still getting a few questions coming in as well.
Okay.
About the resonance tube, someone says they often struggle to get a good result, and it's about electrostatic combat static charge. Would it be the same as a cloud chamber? You just rub something against it to get rid of the static charge, or?
Yeah, so if you see on this resonance tube now, I am having some static issues. What we would suggest for that is just getting like a damp cloth and just gently wiping it, and that should remove some of the static. It is difficult. You can, I did see, I don't know if anyone's heard of that Dr. Dan Jones. I did see that I think it was him. I think he put something on YouTube or PTNC, I think. And it was basically showing like a static gun, an anti-static gun. I don't quite know how expensive they are, so it might be an expensive solution. But basically, I think you just zap it at something that has static and it just gets rid of it. So that might be an option. But yeah, I definitely recommend the damp cloth trick just to see if that works. With this one, it's super, super easy to get those striation patterns. And even with the cork dust in the smaller bore tube that we do, if you watch my video, you'll see the surprise on my face just at how easy it is to get that pattern. So yeah, please do check that out. Shall we quickly do spot the racks? That's a funny one.
Yeah.
Yeah.
You can use your laptop for that one.
Probably, yeah. Right, bear with us again, folks. Last one. If I stop you spotlighting.
We want to do a overshot of tube.
Oh yeah, maybe. I can do that with the laptop. Spotlight for everybody.
Get that over there.
Yeah, okay. Right, okay. Bear with me. I just want to show you one last really fun activity. And it's to do with Lascells law. So this is something called Splat the Rat, and it's to do with a copper tube and some magnets. So just to kind of show you the principle, do you want to try and hold my laptop above this and see? Is that the best way to do this?
No.
So if I pass a magnet through a copper tube, where are we? Should we try here?
Get over the table so you can see through the tube.
Okay, is that about the right angle? Do you want to get your phone, or what do you think?
We can see through the tube just about.
Can you? Okay, right.
Yep.
I'm going to slip the magnet through it, and then hopefully you should be able to see that it's like traveling in slow motion.
That's a better angle. Yeah, that looked good. That was slow motion.
Oh, nice. So this is a really weird effect, right? We've obviously got a magnet here and a copper tube. Copper isn't magnetic, it's not sticking to it, but still we are seeing magnetic effects as it travels through the tube. So this is what's known as Lenz's law, and it means that a time-dependent magnetic field or a moving magnetic field is going to create a curling electric field, which in turn creates another magnetic field which directly opposes the original magnetic field, and that is why we get that braking effect. Now, what we've got here is a massive copper tube. Where are we going to do this? It's that little bit of water.
Yeah.
So with this kit, you will get a big length of copper tube, a bat, that's yours, and then 2 rats. So I'm first off going to use the black rat. So if I put this up here, can you see the end of the tube on there? So it's small, isn't it? Yeah, okay. So I'm going to get the black rat and I'm going to put it through the top of the tube, and I'm going to say to Steve, right, ready? 3, 2, 1, drop. Oh, no, he didn't hit it. Try again. Thank you. Again, 3, 2, 1, drop. Right, so the idea would be is that you'd actually get good at that at some point, and you get used to the timing, and then all of a sudden the teacher would say, let's try this other one. So the red one, there we go, 3, 2, 1, drop. Now, obviously, this one is magnetic, so it's traveling a lot slower. So then you leave your student thinking, oh my gosh, what's happening here? And then you can introduce the principle of Lenz's law and do all of that lovely explanation. So you're still doing the hard-hitting physics, but you're hiding it inside a game. And yeah, I think that's a really lovely piece of equipment. That is the one demonstration that I remember from university. Rob Jeffries did that,
Yeah.
and it stuck with me for a long time. Yeah.
It doesn't look real, does it?
It doesn't look real. It's like, have we changed gravity? Is time dilation happening? Yeah, it's cool. Right, so that is all of the demonstrations that I wanted to get through today. So yeah, please do feel free to fire any questions. Really thankful for your time. Obviously appreciate such a massive cohort joining today. Yeah, that's really encouraging. So thank you for your time.
Thank you, Nick and Steve. That was good and very brave. You to do it all live as well.
Yeah, sorry for the changeover difficulties. Yeah.